Here we'll use implicit differentiation to take the derivative of y squared plus x times y. We are going to have to use a product rule here for x times y. I'm going to call the first factor x and the second factor y. I may not remember the product rule for differentiation from our derivative rules. The product rule is the derivative of the first times the original second plus the derivative of the second times the original first. I'm going to have to use that for the x times y because I have two variables multiplied together equals 7 on the right. Now we're going to take the derivative of each term. So first of all, the derivative of y squared is just going to be 2y. And we need to put a dy dx on it because we took the derivative of y with respect to x. Plus the derivative of x squared is just simply 2x. It wasn't the derivative of y, so we do not need a dy dx on it. Plus, now I'm ready for my product rule. I have the derivative of the first factor to do first. So derivative of 1x is just 1. We did not take the derivative of a y term, so we are not going to put a dy dx on this. Derivative of 1x is 1. And that's the derivative of the first that gets multiplied by the original second, which is y. Product is plus. We did the derivative of the first, original second, plus now the derivative of the second factor. Derivative of 1y is going to be 1. And we're going to need to put a dy dx on this. I'm going to leave some space. Normally, I'm going to put dy dx at the end because we're going to solve for it, and we are used to seeing 5x, not x5. So we're used to seeing the variable we're solving for written last. So derivative of the second factor is 1 dy dx times the original first is x. Times x in there. Equals, the derivative of 7 is 0. Is it okay to write that term 1x dy dx as being dy dx times x? Yes, it's just not how our brains are used to seeing it. So I'm going to keep it at the far right. Now I need to solve for dy dx. So I'm going to move everything that's not a dy dx to one side and everything that has a dy dx to the other. And it doesn't matter which side you choose, but this time I'm going to keep the dy dx on the left, and anything without it I'll move to the right. So going term by term, do I want to keep or move this 2y dy dx? I'm going to keep it. I'm going to keep any dy dx on the left. So I'm going to keep 2y dy dx on the left. Now I'm thinking about my next term. It's 2x. It does not have a dy dx on it, so I'm going to move it to the other side. Just because I said we're going to keep dy dx's on the left, anything without it should move to the right. We're combining like terms here. Next one, we have a plus 1y. That does not have a dy dx on it, so I am going to move it over. I'm going to subtract y over. And then we have 1x dy dx. That has a dy dx on it, so I'm going to keep it on the left. So I go through and I decide, do I need to keep or move each term? So I kept the 2y dy dx plus x dy dx, or 1x dy dx if you want to write the 1, equals, on the right I had a 0, and I subtracted over 2x minus y. And again, that 0 came from taking the derivative of 7. So don't forget to take the derivative of the right side, even though it was much easier than the left side. Don't keep it a 7, take the derivative of 7 to be 0. So now we moved all the dy dx to the left, and we want to get it on one side by itself. This is probably the trickiest step to recognize what you have to do next. If it feels like you're stuck on these implicit, you probably have to factor. We want to factor out dy dx so that we have it on one side by itself. So I know most of us do not like factoring, but this is probably the most straightforward factoring. You pull out a dy dx, and then you just think about what was it multiplied. For the first term, it was multiplied by 2y, and the second term, it was multiplied by plus x. So pull out the dy dx, it was multiplied by 2y plus x, and on the other side, we have minus 2x minus y. My last thing, I don't have dy dx on one side by itself just yet because it's multiplied by 2y plus x. So we want to get rid of that multiplication by doing division. So So we divide both sides by 2y plus x. That way dy dx, the derivative of y with respect to x, we've solved for the derivative, is negative 2x minus y over 2y plus x. There is my derivative. So a simple derivative, take the derivative of both sides. The hardest part about the derivative was obviously the product rule, but then I think the solving is a little bit trickier. You want to move dy dx to one side by itself, anything without it to the other. Then you're going to factor out to get dy dx on one side and then divide so that it's on one side by itself.